Now we are seeing expression for circumferential strain in thin cylindrical shells, that is pressure vessels. So here the fluid present in the cylindrical shell, that is pressure vessel, will apply force in all directions at the same time. So the force applied in the or the force acting along the lengthwise direction will produce a stress which is called longitudinal stress, that is suppose represented by sigma t, and the force acting in the circumferential direction means along the diameter direction will produce a circumferential stress or hoop stress. So it is represented by sigma h or sigma c. So this stress which is acting along the lengthwise direction will produce longitudinal strain, and the stress, because of the stress which is acting along the circumferential direction, will produce the circumferential strain. So here, to write the equation or expression for circumferential strain, so from the basics we know that Young's modulus we can write stress by strain. From that strain we can write stress by Young's modulus. So here we require a circumferential strain means we will write circumferential stress by Young's modulus. And to get the total actual circumferential strain, we are removing this term from this term. So why to remove this term means, see here, the circumferential stress which is acting along the diametral direction will produce positive circumferential strain, and at the same time there is a load or force acting along the lengthwise, that is producing the longitudinal stress. So this longitudinal stress will produce negative or a decrease in the diameter strain, or it will produce negative strain. So here you can observe that this force or this stress is increasing the length of the shell or pressure vessel, and at the same time it is decreasing the diameter, such that this longitudinal stress is producing the negative strain in this uh, pressure vessel. So the stress which is acting along or in the diameter direction is producing positive strain, and this stress acting along the lengthwise is producing the negative strain. So to get the actual total circumferential strain, we are removing this term. So let us see how we can remove this term from this to get the total circumferential strain. So from the basic definition of Poisson's ratio, we can write lateral strain by longitudinal strain. So let us consider the stress in the length direction, that is longitudinal stress. So this is the actual main direction, let us consider here. So in this case, this direction means the stress or the strain in this direction will be the lateral strain, means we are considering the load or stress in this direction. So the strain in this direction will be the longitudinal strain or the primary strain, and the strain because of this stress is nothing but lateral strain. So if we consider this one, so Poisson's ratio 1 by m, we can write lateral strain means this circumferential strain EC dash. So here I am writing dash. Why? Because we are writing strain because of circumferential strain because of this longitudinal stress. So I am writing dash here. So EC dash represents the strain, the lateral strain because of the stress in the length direction or the longitudinal stress. And anyway, the strain in this length direction because of this longitudinal stress will be the longitudinal strain. So EC dash by EL. So that is nothing but Poisson's ratio. And here, if I write AC dash, it is nothing but EL, strain in the length direction or longitudinal strain, into Poisson's ratio. I am just cross multiplying the terms. So here I can write this longitudinal strain nothing but longitudinal stress by Young's modulus, which is once again from the basic definition. So if you write E here, this will be strain. If you write here, stress by Young's modulus, and I require longitudinal strain means longitudinal stress by Young's modulus. That longitudinal stress we have assumed sigma t by Young's modulus into 1 by m, and if you rearrange the terms, we can write EC dash is equals to sigma t by me, which is nothing but strain in the circumferential direction because of the stress, that is because of longitudinal stress. So we can observe that this is a negative strain, means this stress in the length direction, that is longitudinal stress, will produce negative strain in the diameter direction. So this has to be minus removed from this one. So we are writing minus of this sigma t by me from this. We are removing this strain from this strain to get the actual total circumferential strain. So we are writing the once again this equation here. So EC, circumferential strain, is equals to sigma c by E minus sigma t by me, where 1 by m is a Poisson's ratio. So here we can write sigma c, circumferential stress or hoop stress. We know the formula, it is PD by 2T. So if you write PD by 2T, and it is PD by 2T, E is there, and minus sigma T, longitudinal stress, is nothing but the formula is given by PD by 4T, and if you substitute here, it is PD by 4T into ME. And if I take out PD by 2TE common, here we will get 1, and here 1 by 2M. So once again, it is nothing but circumferential strain is equals to PD by 2T into 1 minus 1 by M. So this circumferential strain is nothing but strain in diameter direction. So from the basic definition of strain, we know that change in dimension by original dimension. So it is in the diameter direction, means so change in diameter by original diameter, which is nothing but circumferential strain or strain in the diameter direction. So this is the expression for the circumferential strain in a thin cylindrical shell or pressure vessel. So for more videos, please subscribe and activate bell symbol. Please like it, share it with your friends, and don't forget to subscribe. Thanks for watching.